So we're continuing with section 16. I'm talking about properties of logarithms. So just a refresher on these properties. So if you are adding the logarithms, you can convert it to a product. Subtracting logarithms, you can convert to a division. If you got a number outside of the logarithm, you can change it to the power. And then the change of base. If you've got something in an odd base, you could take log of the value over log of the base to find out what that is. Here's another couple just standard definitions for our properties. So this is where we're using the common base, the common logarithm using the change of base. So log base 8 of 15, we would take log of 15 over log of 8. You can do that in your calculator really easy. So we want to express each logarithm in terms of the common logarithm and then approximate its value. So first things first, we've got 5 to the 4th. We need to pull that guy outside. That power of 4, we can bring it outside. So then it's 4 times log base 6 of 5. So now we can rewrite it in our change of base. So log of 5 over log of 6. Plug that into your calculator. I didn't do as many decimal places. I only did 2. So I get an answer of about 3.59. So same thing here. We got 4 to the 5th power. We want to pull that 5 outside. So we have 5 times log base 8 of 4. So change of base, log of 4 divided by log of 8. We get about 3.33. Same thing here. We got to pull that 6 outside. So then we have log base 2 of 3.6. Change of base, log of 3.6 divided by log of 2. And this will get you about 11.09. Here we want to pull the 4 outside. So we've got 4 times log base 12 of 10.5. So rewriting in our change of base, log of 10.5 over log of 12. We get about 3.79. So first I want to rewrite this as an exponent. So 150, square root of 150 is the same thing as 150 to the 1/2. So that 1/2 I'm going to pull outside. So we have 1/2 log base 3 of 150. Now we can do our change of base. So I have 1/2 log of 150 over log of 3. We get about 2.28. Same idea here. We want to rewrite this as an exponent. So cube root of 39 is 39 to the 1/3. So we're going to pull a 1/3 out and then rewrite with our change of base. So 1/3 log of 39 over log of 4, get about 0.88. So sometimes we're going to have to do multiple things at once, combining here. So we start out with our equation. Since we have the 2 outside, we can put it back inside to become an x squared. Then we're subtracting these logs so we can rewrite it as a division. At this point now we've got a common base of 3, so we can set what's inside equal to each other. So x squared over 4 is equal to 25. And then we get solutions of plus or minus 10. Now, just a reminder, logarithms are undefined for x is less than 0. The domain of a logarithm, x has to be greater than 0. So that means that negative 10 is an extraneous solution. We only have the one solution of positive 10. We got a similar problem here. This time, though, we're adding the logs. So we're going to rewrite it now to become a product. So x times x plus 2. At this point, we can circle the wagon. So 2 to the 3rd is equal to x times x plus 2. You come up with a quadratic, and then you factor and get 2 solutions. So again, key thing here, you have to check if you're getting negative values for x. Make sure you plug it back in. Our logarithms have to be greater than 0. All right, let's work through some problems. So here we're adding the logs. So that means we want to rewrite it as a product. So log base 5 of 4 times 2x, which is 8x, is equal to log base 5 of 24. So now that we have the common base, we can set the two parts equal to each other. 8x is equal to 24, so x is equal to 3. We're subtracting here, so we want to rewrite it as a division. So log base 2 of 4 divided by x plus 3 is equal to log base 2 of 8. So now that we have the common base, we can set the two parts equal to each other. 4 over x plus 3 is equal to 8. Multiply both sides times x plus 3. So 4 is equal to 8x plus 24. Once you distribute that, subtract the 24 to get negative 20 is equal to 8x, and then divide. You'll end up getting x is equal to negative 5 halves. Now, normally you think, okay, we're probably going to have to throw out the solution. But if we think about it, when we plug this back in up here where for our x, negative 5 halves plus 3 ends up being a positive 1/2. And so that means this is an okay solution since our logarithm does end up being greater than 0. So even though x is negative, once we plug it back in, we're getting a positive value inside of our log. So that means our solution is still a-okay. All right, this one here, we've got that 2 on the outside, so we want to bring it back. That's going to become a power. So log base 4 of x plus 1 squared is equal to log base 4 of 11 minus x. So common base, we can set the two parts equal. I'm going to go ahead and distribute, do that product of x plus 1 squared. You get x squared plus 2x plus 1 is equal to 11 minus x. So now we've got a quadratic. We're going to move everything over and then factor. So this becomes x plus 5, x minus 2 to get us solutions of negative 5 and positive 2. So looking at plugging this back in, we want to check that negative 5 answer. If we do negative 5 plus 1, we get a negative 4. So that means we're going to have to toss out that solution. We only have the one solution of x equals 2. All right, last two problems. First things first, I see that 3 on the outside. I'm going to plug that back inside, and then I'm going to do two things at once here. I see it's subtraction, so I'm going to rewrite it as a division. So log base 2 in the numerator is going to be x. Denominator then is going to be 5 to the third if you bring that 3 back inside to that power. So that's going to be equal to, and I'm going to bring this inside as well, log base 2 of 10 squared. So now that we have that common base, we've got x over 5 cubed is 125, 10 squared is 100, multiply, x is equal to 12,500. Here we're dividing, we're subtracting, so we rewrite it as a division. Log base 3 of c plus 3 over 4c minus 1 is equal to log base 3 of 5. Bases are the same, so we can set the two values equal. Multiply by that 4c minus 1, so we get 20c minus 5 once you distribute. We're going to subtract the c, we're going to add the 5, and then we can divide. C is 8 over 19.